Before you can start overhauling the pistons, there are several preliminary steps you'll have to take. Orderly work habits make any job easier to do. With your tools laid out and an engine manual handy, check in the cabin to be sure the ignition switch and fuel shutoff valve are off. Make the various disconnections at the engine and pull all the cylinders. Now remove all the pistons and carry them to a work table. After the cylinders have been reconditioned, the next job is to clean, inspect, and repair the piston parts and to check clearances to determine how much wear has taken place. You'll find an exploded drawing of the piston assembly in your engine manual. When inspecting and reconditioning pistons, you'll be concerned with the piston itself, the piston rings, the piston pin or wrist pin as it is more commonly called, the piston pin plugs, the bushing in the connecting rod, and the connecting rod itself. Here's the way these parts go together. The piston pin bushing in the connecting rod actually is a pressed-in part of the rod and is not removed during an overhaul. The connecting rod fits into the piston in this manner. The piston pin plugs fit snugly into the ends of the piston pin, like this. The piston pin is then inserted through the piston and the connecting rod bushing and holds the piston to the connecting rod. The piston rings are installed around the piston. And eventually, the piston assembly will be installed inside the cylinder. There must be correct clearance between these parts to assure proper lubrication. One of the most important is the clearance between the outside of the piston and the inside of the cylinder. The two surfaces at the ends of the piston pin, where the pin fits into the bosses in the piston, also must have proper specified clearances. And the center of the piston pin, where the pin goes through the connecting rod bushing, likewise must fit properly. Now let's get back to the pistons themselves. Take a good look at the piston rings. They may give you a clue to trouble. These rings seem to be okay. An example of what you may run into, however, is this piston from another engine. Some of the rings are seized. That is, overheating has welded them tightly to the ring grooves. Notice the blow-by marks on the rings, where hot expanding gases have escaped. A condition like this would most likely score the cylinder seriously, like this, and cause a distinct loss of power. However, the rings on the piston you are inspecting are in good shape, and you can go ahead and remove them. To get them off easily, you'll need a ring spreader that grips the ends of the ring and spreads the gap. When you have all the rings off, you can start cleaning. And this is a lengthy job. The heaviest carbon can be loosened with a scraper. You can make a scraper by putting an edge on a piece of aluminum, like this one. If you make a scraper, be sure to use soft metal that won't scratch the piston. You'll need another scraper with one end narrowed to fit the ring grooves. When most of the carbon has been scraped off, the parts are ready for a soaking in cleaning solvent. Keep the pistons, pins, and plugs in sets so they don't get mixed up. When using some of the harsher cleaning solvents, wear rubber gloves to protect your hands. This cleaner is mild enough to make that unnecessary. Let the parts soak until the solvent has had a chance to loosen the remaining carbon and dirt. When certain kinds of cleaner are used, it's necessary to rinse off the parts with hot water. Now you can probably get the parts thoroughly clean with a little more scraping. Getting pistons that have had a lot of use clean is a painstaking job. But when you're finished, each one of them ought to shine like new. Poke out the oil relief holes spaced around the head with an undersized drill to be sure no dirt has clogged the openings. Now you can finish off the cleaning job in good shape with a spray gun and cleaning solvent. The gun will force cleaning fluid into all the corners. Then the same gun, disconnected from the solvent, will dry and further clean the piston with compressed air. After inspecting each of the piston pin plugs, try them in the piston pin for fit. This one is too loose and should be discarded. Make a note to get a new plug for this pin. To detect cracks or scoring that you might otherwise miss, use a 10-power magnifying glass. Here's a nick that can be repaired. Use a fine stone dipped in oil to smooth the nick down, following the contour of the pin with the stone. Then polish the spot with a piece of crocus cloth. Now you want to check the piston pin for straightness. You'll need a dial indicator and a pair of V-blocks set up on a surface plate. Lay the pin in the V-blocks and place it directly under the indicator arm. Set the dial so the needle points to 0. As you rotate the pin, watch the dial for any variation. This pin is perfectly straight. Next, you want to measure the diameter of the pin at each end, where it fits into the bosses in the piston, and in the center, where it fits into the connecting rod bushing. You'll remember where these clearances are. Use a micrometer of the right size to get these diameters and have your check sheet handy to record them. You'll use a micrometer many, many times. And, in fact, a good deal of the effectiveness of the overhaul job will depend upon your skill in using this tool. Take 2 measurements at each point and record them. Take the measurements at right angles to each other. If there's a difference in the 2 readings, the smaller is the one to use. Taking 2 measurements at each of 3 points on the 4 pins, you'll have 24 micrometer readings to take. You'll need the magnifying glass to inspect the piston also. Scoring, cracks, or corrosion will show up more clearly. This piston appears to be in good condition. Now you want to be sure the clearance of the piston in the cylinder is satisfactory. You'll recall that this clearance was pointed out. Using the proper size micrometer, measure the diameter of the piston at the skirt and record the readings on your check sheet. Take measurements at 3 points on the bearing surface of the piston at the skirt, and if there's any variation in the readings, use the smallest one. When you measure the cylinder, you recorded its skirt diameter. Now record the piston diameter and subtract to get the clearance. Check this clearance against the table of limits. The piston in the cylinder can have a clearance between 14 and 17 thousandths. That means your clearance is okay. A visual inspection of the ring grooves is next in order. Watch particularly for signs of steps worn into the grooves. Now examine the piston pin bosses for scores, cracks, or evidences of wear. This boss appears to be in good condition. You still need to check the clearance between the boss and the piston pin. To measure the diameter of the boss, use a telescoping gauge and a micrometer. By taking readings in 2 directions, you can tell whether or not the boss is out of round. Record the maximum inside diameter of the boss on your check sheet. A few minutes ago, you measured the diameter of the piston pin where it fits into this boss. Now subtract the diameter of the pin from the diameter of the boss and get the clearance. This clearance must then be checked with the table of limits to be sure it's satisfactory. To complete your check of piston pin clearances, you'll need to go back to the engine to get the diameter of the piston pin bearing in the connecting rod. Use a telescoping gauge and micrometer in the same way you took the diameter of the bosses. Again, it's standard practice to take the diameter in more than one direction. And if there's variation, use the largest one. Now subtract the center diameter of the piston pin from the diameter of the connecting rod bushing. This will give you your final clearance, which must also be checked with the table of limits. Your last job is to install new rings on the pistons. Each piston on this engine has 4 rings, 2 compression and 2 oil control rings. You'll have to check the gap of each of these rings. To do this, you'll need the cylinder. Install the piston in the cylinder barrel in its operating position. Now wipe the ring clean and dry so you'll get an accurate measurement. Then compress the ring and place it in the cylinder. Pull the piston out so it will square up the ring. Use a feeler gauge to check the gap of the compressed piston ring. You'll find proper gap allowances given in the table of limits. It's not unusual to find the gap too small. When you do, you'll have to file the ends of the ring down. To do this, clamp a smooth file securely in the soft-jawed vise. Then hold the ends of the ring squarely against the file so the ends will remain parallel and move the ring up and down. When you feel you've enlarged the gap sufficiently, make another check. This ring is okay now. Each new ring should be checked in the same way to be sure the gaps are those specified in the table of limits. The next step is to install the rings. First, set the piston down with the open end facing up. The right ring must be installed in the right groove. This is an oil scraper ring. Notice the undercut edge. Grip the ends of the ring with the ring spreader. This oil scraper ring should be installed with the undercut edge toward the open end of the piston. Now turn the piston over so you can get at the other three grooves. Install another oil ring having a similarly undercut edge next. This ring is also installed with the undercut edge toward the open end of the piston in the third groove from the top. Next, install a plain compression ring in the second groove from the top. And finally, install the top compression ring in the top groove, with the beveled edge toward the top. On some engines, the top of the ring is marked to avoid confusion. One more check you'll have to make is for side clearance of each ring in its groove. The allowable clearance for each ring is given in the table of limits. Hold the ring firmly seated in the groove when you use the feeler gauge and run the feeler all the way around the piston. This top compression ring fits too tightly in the groove. The proper feeler gauge can't be inserted. That means the ring will have to be lapped. Use a smaller gauge to determine how much metal will have to be removed. Before lapping, mic the ring all around. Then, when you mic it again later, you'll know how much metal you've removed. The lapping tools you'll need are a surface plate, emery cloth, and a wood disc with a groove to hold the ring. Lay the ring squarely in the groove with the top side up. Lap with a light touch, moving the ring evenly over the emery cloth. To avoid heavier lapping, where your fingers touch the disc, move the fingers often to different positions. Check the ring frequently so you don't lap it too much. Take it out of the disc and wipe it off before making it so you'll get an accurate measurement. Then use the micrometer at short intervals all the way around so you'll know if you're lapping evenly. You may have to stop lapping and mic the ring several times before you have it just right. give it a final check with the correct size feeler gauge. You may find it necessary to lap all the new rings, or you may find some of them satisfactory. With the new rings installed, your overhaul of the piston is finished. Each piston is gone over with the same care and put into first-class condition. Before reinstalling the pistons, however, the valve assembly must be serviced. That operation will include taking the valve assembly apart, cleaning the parts, inspecting them carefully, checking the tension of the springs, measuring the parts to check clearances, refacing the valves where necessary, and finally, lapping them into their seats.